Day grade 10s. How are you guys doing today? Welcome to this physics lesson where we're going to be looking at the topic machines and efficiency. In the last lesson we looked at work and power. We looked at work and power, how we get to calculate work from force by multiplying force and the distance moved, and then power being the rate at which work is done. So if you have work done and you know that work is done in a certain number of seconds, then you can actually get to calculate the amount of power that was used to do that work. Now we want to move on to machines and efficiency. You will find that part of it, we already talked about some of this in terms of the levers when we talked about a moment of force, right? But we're going to look at machines specifically in the form of levers, gears, and pulleys. Levers, gears, and pulleys. And we are also going to talk about efficiency. We're also going to talk about efficiency, how to calculate the efficiency, what efficiency is. So effectively, first we'll have to look at what efficiency is and how we can calculate the efficiency of any machine that we are going to be using. Okay? So a machine is a device that causes a change in the way forces act. Right? So if you have a force and a force is being applied onto a particular body, then a machine is going to act as a force multiplier. It's going to change. Right? It's going either, if it's a good machine, it's most likely going to increase the amount of multiply the effort that you would have applied on an object, right? So as to allow you to actually apply less effort. So you apply less effort, the machine multiplies the effort and therefore makes work easier for you, right? The first type of machines that we're going to look at are levers. Okay, they are levers, and let's just watch this short clip on levers.
Lever is one of the most basic forms of a machine. They help us lift loads with lesser effort. Even though this looks simple, there are so many things going on in order to lift the object easily. A lever can be described as a long rigid body with a fulcrum along its length. Load, the object you're lifting, fulcrum, point at which the lever pivots, effort, the force applied to make the object move.
Okay, so I hope you're able to see the different parts of the lever. Trying to bring this back a bit. Right. Okay, so if you can look at the different parts of the lever, don't think of the lever in the form of a crowbar only. We have different types of levers, right? That's why they're showing you different aspects
the object move
of the lever. To say it's going to have a pivot, you're going to have part where effort is applied, and the pivot, the load, the effort. Those are the three aspects of a lever.
We use levers in so many of our day-to-day activities. They are classified into three categories depending on the relative position of the load, fulcrum, and force. The first class lever, where the pivot is in between the effort and the load. The second class lever, where the load is between the fulcrum and the effort. The third class lever, where the effort is between the fulcrum and the load.
Okay, right. So those are the three types of levers. We say first order, second order, third order. So three orders of levers, right? So I hope I explained those when we're talking about moment of the force, but if you just go back and then look again in this video, you will see that the first order, second order, third order are only differentiated by the position to say where is the effort being applied, where is the effort, where is the pivot, where is the load, right? And the position of the load will tell you which order which order the lever is, if it's a first order lever or it's a second order lever, right? Another type of machine that we have is a gear. Okay, so we use gears which I hope you've seen gears before. If you've ever rode a bicycle, right? If you ever rode a bicycle, bicycles actually have where you'll be pedaling, you will see that there's a gear there, right? And a gear is a system of wheels with interlocking teeth so that one wheel drives another by transferring force from one gear to another. So if we look at this gear in this question, we have gear A and gear B. And gear A is bigger, right? It's bigger. And we'll assume, let's say, it's twice as big as B. So for every rotation that you make on A, you move B twice. For every rotation you make, depending on the type of gear, right? So you have a situation where just by rotating the first gear once, you maybe rotate the second gear 4 times. So that's why it says here that it requires less effort to turn a large gear slowly than to turn a small gear quickly. So the effort that you're going to apply on the large gear, right, is going to be less effort, but it's actually going to end up having a resultant output, right, for this output gear. So we have what we call an input gear and what we call an output gear. An input gear and an output gear. A being the input gear with the one which you are rotating, B being the output gear. But we're saying, just imagine you want to make the rotations and you just make a single rotation or 2 rotations on the input gear and it gives out an output of 4 rotations on the output gear. So your effort has been multiplied. And that is just the basic concept of a machine. That is it has to be a force multiplier. It has to be a force multiplier, right? Then the efficiency of the gear can be improved by doing lubrication, by using appropriate shaping of gear teeth, proper alignment of gear teeth to reduce friction. We are going to talk about efficiency in detail in just a few minutes, but that's basically how you improve the efficiency of a gear. Okay? So the next thing we want to look at, just go over again the levers and the gears, just read about it and see if you can get a clear understanding. Okay, so the next thing we want to look at now are pulleys. These are pulleys. I hope you've seen pulleys before. I'm sure you've seen a mechanism such as that of a pulley before, right? And we're saying that a pulley is a wheel with a groove through which a rope or belt passes, right? And what you're going to be doing is, when you're using this pulley, you're going to be lifting, as you can see on the first object. You are now pulling the object or your load, you're pulling the load down. And when you're pulling the load down, the main concept and the main essence of the pulley is that when you're pulling down, you also now have the force of gravity on your side, right? So instead of lifting something up, imagine a big weight, okay? Imagine a big weight and you want to lift it up. If you are lifting it up, you are actually opposing gravity. You are fighting against the weight of the object and the force of gravity. But now when you use a pulley, you are actually going to be pulling the weight, but now gravity is also helping you because now you're pulling it up, but the rope is being pulled down. Okay, let's watch this.
Only human force. This problem can be fixed with the help of a simple machine like a pulley. What is a pulley? A basic pulley comprises of a wheel on a fixed axle with a groove along the edges to guide a rope or a cable. The load is the weight of an object and effort.
Okay, so if you look here, you find that the load, you are pulling the load up, right? The effort, the amount of force required to lift or move this object. But we're saying that the issue here,
the amount of force
you find it is good about what is called the pulley is that when you are now pulling down, gravitational force is now actually helping you to pull down, right? Because now you're pulling it down, you're pulling the load up, but your effort is now also aided with the pull of gravity.
Force required to lift or move this object. When you put two or more wheels together and run a rope around them, you have created a great lifting machine. As you
Right, so these are now multiple pulleys. Let's see here. Here you see that on this diagram you have what we call a single pulley, and those are two pulleys, right? Multiple pulleys, and included in your notes that if two or more pulleys are used, the machine becomes a force multiplier as well as a direction changer. Because the main issue about the pulley is that one is a direction changer, the direction of effort. So your direction of effort is now downwards. And when your direction of effort is downwards, it's aided by gravity. Now when you use two or more pulleys, the force that you're applying is actually multiplied by the number of pulleys. So if you're applying a force of 50 newtons and you want to carry, let's say the object, the load is 100 newtons, what you'll have to do is you'll have to apply 50 newtons, and what's going to happen is that those 50 newtons will actually be enough to carry that 100 newton load, because already the force, you have now changed the direction of the force, and the pull of gravity is actually helping you now. That's why you can use a lesser force to lift a bigger load. When you now use two or more pulleys, what then happens is that those two pulleys then get actually to multiply the force you are applying, and it makes it actually much easier for you to lift that load that you want to lift. So we also have ways of improving the efficiency of pulleys, so you can look at those. And finally, before we finish the lesson, let's look at efficiency itself. So if you can look at the definition of what efficiency is the ratio of work output and work input. Work output over work input. Because what's going on with this concept of efficiency? What you're going to do is, obviously you're going to read all of this stuff, but I'll just give you a brief outline that whenever you do work and whichever machine you use, it's not always going to be 100% efficient, because there are always going to be things like friction. If you are using that pulley, some of your energy and some of your effort is going to be lost in just overcoming the force of friction and not actually lifting the load. Just imagine if you were pulling a damaged, or if you were pushing a wheelbarrow, and the wheel on the wheelbarrow keeps on scrapping either to the base of the wheelbarrow. It means it's actually going to be much slower, right? It's actually going to be much slower, so the efficiency is less. So work output is just a case of saying how much has been produced. If I put in 50 newtons, if we put in 50 kilojoules of energy, did we also get out 50 kilojoules of energy, right? And you multiply that and you say, so we have what? 100% efficiency. But then if you put in, with most machines, if you put in a certain amount of energy, you will find that less will be produced, because some of the energy is actually lost in the form, either in the form of heat or in the form of sound. You just imagine something like a torch. The torch, do you know a torch? The one you use to light, like the ones you came with when, which we say if there's no electricity, then you use your torch. The torch, its function is to provide you with light. But that torch is going to also, if you fill it, you're going to feel that the bulb is going to end up producing some heat. So now the heat is not what the torch is meant to produce, So that's actually a loss of energy. And it therefore means that torch is not 100% efficient. So what I did is I put in several questions here for you guys to do. What we're going to do for these ones, we're going to do, I think, only number 1 and 2 together in the class, and then 3, 4, and 5. Is it number 5? Okay, 3, 4. 4 has several parts. Part A, item 1, item 2, item 3. So when you read through this concept of efficiency, just observe number 1, a car engine, a car engine consumes. It's supposed to be consumes. I'll correct this if I don't correct it. Please just know that it reads: a car engine consumes 2,000 kilojoules worth of fuel every 30 minutes. Of this, only 1,000 kilojoules is converted into mechanical form. Okay, mechanical form, which is the actual movement of that car engine or good use of the energy. So now, if 2,000 kilojoules worth of fuel are being consumed and only 1,000 kilojoules is converted into useful mechanical form, for you to calculate the engine's efficiency, you're going to say useful energy output divided by total energy input, which is the energy that was produced, which is 1,000 kilojoules, energy output, divided by energy input, which was the 2,000 kilojoules. And you say 1,000 divided by 2,000, which would be 0.5, or 1 over 2. Then you multiply it by 100, because efficiency is a percentage. Efficiency is a percentage. So you say 1,000 kilojoules divided by 2,000 kilojoules multiplied by 100%, and you get 50%. Okay? And you get 50%. Says question, the item B suggests possible forms of energy into which the engine is wasting energy. Heat and sound. Heat and sound. So if you're going to have a car and the car is just going or the engine is just hot, that's not what the engine is meant to do. The engine is meant to propel the car forward. So that is actually a loss of efficiency, a loss of energy. So this engine is only 50% efficient. So the other questions, like I said, you do them by yourselves as this week's homework. So I'll encourage you, please, to just go back and look at that. Also, other types of machines, inclined planes, wedges, different types of machines. I would advise you and I would encourage you just to read up on these different types of things and have a wider base of knowledge. So that's our lesson for today. Thank you very much.